All right, I think this is great timing, having my presentation go after Larry and John's, because they're very related, and one of our sites is actually in the Waco corridor where you just heard about. So I'm going to give a presentation on the variable speed limit Texas pilot project. If you were at Short Course last year, we were in the very beginning stages of this project, and so we actually now have something that's operational in 3 locations, so we're going to give you an update. But bear with me a little, and I'm going to give you some background information for those of you that may not be very familiar about what variable speed limits are and why an agency like TxDOT might want to use them in corridors. So variable speed limits are, in a simple definition, they're just a speed limit that changes when activated based on a variety of conditions. They have a lot of other terms that you might hear bandied about, like speed harmonization or flexible speed limits. There's a lot of different ways that they're used, but variable speed limits is pretty straightforward, and that's the term that's most commonly used. And the conditions that might trigger variable speed limits would include construction, a work zone application where you have congestion that's building, a regular congested corridor where on a daily basis you have congestion that builds just because of traffic and conditions, and then weather. So there's a variety of weather applications that might generate a need for variable speed limits. And the idea is to use technology to monitor the conditions of the facility and trigger that variable speed limit as conditions warrant, so that the drivers are aware of the conditions that are occurring. The first application of variable speed limits in the United States was in Michigan in 1960. I believe it might be the photograph in the middle. It's a very simplified version of doing variable speed limits. They have been used in Europe for many, many years, at least 3 decades. And those are the sites that are listed there. In the bottom left-hand corner is an application in Denmark that was done a number of years ago on a major reconstruction project very similar to the I-35 construction project, and they used variable speed limits during the construction to alert drivers to congested conditions. And just an anecdote on that project, they found that they saw no increase in crashes during this major reconstruction, and they attributed it to the variable speed limits and their traveler information messages that they gave during the construction. The one on the bottom right-hand side is in Germany, and the one above, sort of in the middle of the slide, is a deployment on a bridge between Denmark and Sweden. So it has been used. The one on the top right-hand side, I believe, may be the New Jersey Turnpike. So it has been used. The more current applications are on this slide. It's the purple dots. And they've primarily have been used most recently for weather-related applications. So you have a condition where you have low visibility, you have snow, driving rain, ice on the pavement, and the speeds need to be reduced. The one in the center bottom of this slide is an application in Washington State, and it's a pass through the mountains outside of Seattle that regularly had crashes because of weather-related conditions, and so that was a deployment there. The one on the left-hand side is the regular congestion application in Seattle. The one on the top right-hand side is in Minneapolis on I-35W through Minneapolis, so that's in their application. So there's a lot of experience with it in specific locations, and so interest has grown in doing these types of strategies to improve operations. So why would you use variable speed limits? Very similar to the applications on the I-35 corridor. When you have congestion building, there's a lot of instability in the traffic stream. And so you may have one driver that's going 55 and another one that's going 70, and they're not paying attention to what's going on, and they come up on the back of a queue that's building very quickly, and they're more likely to have an accident. And so variable speed limits helps operational agencies get some control over the speeds that are out in the field. And so if you have a queue building, you can use those variable speed limits to control the slowdown as the vehicles come up on the back end of that queue. If you have a work zone where you have a lane closure, it operates the same way. Let's work to help the speeds become more uniform so you have less erratic behavior in the driving stream and you're less likely to have some sort of an incident. And the smaller those deviations between different speeds, the less likely you are to have that instability. So there's 3 applications that are typically used to activate VSL, and I've mentioned those before. Congestion, where you are measuring speeds, volumes, and occupancies on the corridor, and an algorithm running in the background, a lot like the queue warning when the smart people come up with the algorithm. And when the data coming in says we have congestion building, let's trigger the VSL, then that's the first application. Lane closures, they function very similarly because you have congestion building as a function of a lane closure or a work zone application. So again, the algorithm triggers the variable speed limits. And then in weather, the 2 typical measures that will trigger the VSL would be pavement surface friction, so that's looking at water and ice on the pavement, as well as visibility. And the visibility could be a function of fog, heavy rain, or snow. In operation, this is a layout you might typically see. The spacing between the individual signs might be anywhere to a half mile to a mile. And the idea is to transition the speeds down slowly so a driver gradually reduces its speed as he comes up on the back of a queue. And the harmonization or the uniformity of that is all done by an algorithm that measures all the traffic out in the field in different segments. So in the activation stage, the variable speed limit, the way it's operated here in Texas and in a lot of other locations, the algorithm running in the TMC determines that the VSL needs to be activated. So the system will alert the traffic management center, and an operator in the traffic management center will get an alert that says VSL needs to be activated. And in this case, an operator will either accept that plan that's being recommended by the algorithm or deny it for whatever reason it might be. And then if the algorithm is accepted, then the system goes into operation and the speed limits start to change. It can change as often as every 2 to 3 minutes based on how quickly that congestion is changing out in the field. And then in the deactivation, it's very similar. Once the need for that VSL goes away, the operator can basically deactivate the VSL and it goes back to the standard sign of what the variables, the speed limits are indicated for that location. In this case, it's 70 miles per hour. So in 2013, the legislature passed House Bill 2204 to authorize TxDOT to conduct a pilot study to look at variable speed limits. Up until that time, VSL was not possible in the state of Texas. And in most cases, the states have to go in and have authorization to do it. So the legislature wanted TxDOT to be able to test it, see if it has the potential to improve congested conditions for a variety of applications. The law passed required that TxDOT select at least 3 locations to look at variable speed limits under 3 conditions that are listed here: construction, congestion, and weather. The bill actually expires in February of this next year. So the study had to be done before February. The law also required that we have advanced warning signs to alert drivers that the speeds are going to be reduced. And TxDOT worked with TTI to develop an interagency contract to help TxDOT with the deployment and an evaluation of these pilot studies. And that's TTI's role. We've also worked with Southwest Research, and I'll get to that a little bit as to why we were engaged with Southwest. So the pilot study advanced warning sign, this is typically what a driver would see if we were reducing speeds as you're coming into a different speed zone. The legislative bill required this sign, and we felt that that was very difficult to install for a short-term pilot study. So we came up with this sign that is just a portable changeable message sign that we put out in advance of the VSL corridors, and it just indicates that there's a reduced speed ahead. And it is connected to the variable speed limit signs. And so when the VSL algorithm isn't operating, this sign just says drive safely. So the pilot study started in January, and we have helped TxDOT along the way with the selection of the 3 sites, the development of an implementation plan, which involved the design of the signs and the system. We worked with Southwest Research to develop the algorithm. TxDOT requested and required that the algorithm function within Lone Star, so that required the partnership with Southwest Research to get that done. And so we worked with them to develop the algorithm. We developed an evaluation plan and equipment assistance. So we worked with procuring the equipment, and were able to leverage some of the existing contracts with the I-35 project to expedite this because we had such a short time frame. And then we helped implement the equipment, and we are helping maintain it while it's out in the field, and we're under the evaluation stage right now. We currently have all systems operational through the end of October. The current plan is to start to stagger them in terms of termination. So one will go through the end, I believe the Waco site will go through the end of November, the San Antonio site will go through the end of December, and the Ranger Hill site in on I-20 will go through the end of January. And all of the sites have to be deactivated by January 31st. So these are the 3 locations. The sign in the inset is the sign that we designed. Again, this was designed because it was a quick pilot project. It was feasible, and it was fairly inexpensive for us to design the sign to provide the variable speed limit information. And we worked with the vendor to develop this, and it has been very well received. We've been able to get them out in the field and have the system operational very quickly. The typical lead time on a sign that you might typically use in this, if it's not on an overhead gantry, might be 3 to 6 months, and we didn't have that amount of time to get them underway. So those are the 3 sites, and I'm going to go through each of those fairly quickly. The construction site is on I-35 between Temple and Belton, as John mentioned, and the only difference between these signs, and John showed you a picture of it. I don't believe I have a picture of it. And the one you saw before is it has the work zone placard on it because that was necessary for that work zone. So we use a portable changeable message sign to indicate where these signs, where the variable speed limit corridor is. And so the way it works is this sign, this is in the northbound direction, and so that's from bottom left-hand corner to the upper right-hand corner. And the first sign on the right is the one that's at that tail end of that queue. So the queues start to build up ahead of that, in front of it. And so we're working to reduce speeds as drivers come up on that congested point so that they don't come up on that unaware and have to slam on the brakes and reduce their speed too quickly. This site, that's the lane closure that we talked about where it's located, and there's congestion within that work zone. This site began on June 23rd of this year. Right after it went live, I think I was at a conference somewhere on the other side of the country, and it activated within 15 minutes of being turned on because we had a huge thunderstorm come through the site. So we found it worked. We were really excited. And actually, I was at a Freeway Operations Committee mid-year meeting, and I'm telling people, hey, our site went live, and hey, it's working. They're really interested in it, too, because a lot of agencies are interested in seeing how this project goes. I know California, I've had several phone calls from them. This site has the pavement sensor, so we're measuring the moisture on the pavement to determine whether or not the system needs to be activated in addition to congestion. Some of the initial observations that we've made as the system went live is we had to modify some of the calibration on the pavement sensor detectors. What was happening was it was activating very quickly, but because it's actually measuring the pavement on the shoulder, that dries slower than the main lanes, so we had to tweak the algorithm so that it would recover faster. We have had some comments about the visibility. If it's in direct sunlight, it's a little difficult to see. We've worked with the vendor to correct that, and we think we have a solution that's going to work very well and won't overpower drivers at night, but in direct sunlight will be able to be visible. And so we did have a thunderstorm that destroyed 2 signs in July. That was not pleasant to go through. And we had another one that went down a couple of weeks ago. But we've managed to get them, the vendor has been fabulous. They've been very responsive, and if we have a sign that goes down, they're out there in a number of hours to help us replace it or repair it and get it back online. So in San Antonio, this is the congestion location, and it's on 1604 between 35 and I-10 in the westbound direction. And this is a much longer segment. Congestion builds on a regular basis, and we have 8 signs out here in this particular location. So it functions a little differently simply because the spacing between the signs is a little longer, and we are trying to control the speeds anywhere within that corridor. So in this direction, you can kind of see how the speeds might start to change and how we would activate it based on the congestion that's building. This site activated on June 30th of this year. It includes the same pavement sensors that we have on the Waco site. And we have seen regular occurrences of the system activating. So it's doing what it's supposed to do. One of the things we're looking at is how quickly it responds to congestion and how quickly it recovers again. And I'll talk a little bit at the end about the evaluation that's going on and how these sites are starting to, they perform a little differently. And so we're looking at the different data coming in to figure out how they perform under all of the conditions. The third site is on I-20 in the Brownwood district, and it's in the area called Ranger Hill. I'd never heard of this until this project, because I don't go up there very often. But this is a steep grade hill where there's propensity to have bad weather, ice and snow, and high winds. So it's a similar section, about 2.5 miles. This site has the signs in both directions. It's the one site where we felt, where TxDOT wanted to look at both directions because it is a problem in both directions. So this is an application there, and this is a layout of how the signs look in each direction. We're trying to reduce the speeds in advance of the hill so that drivers, especially heavy trucks, have control of their vehicle as they enter this steep grade or downgrade, so that there's less likely to be an accident as a result of congestion and high speeds. It activates as opposed to heavy rain. This site also has a visibility sensor because fog or snow or heavy rain and ice can deploy it there as well. So it has the pavement sensor as well as a visibility sensor. It activated on July 21st, and what we have learned is the hot spots for weather are difficult to predict, and as of yet we haven't had any major weather flare-ups. That's one of the reasons that we're going to extend this site as long as possible into the early winter months to hopefully get some winter events where we can see how it performs. Even though that data may not necessarily go into the report that goes to the legislature, TxDOT will get a revised version of that report when we include some of the data from the extensions. So in terms of the evaluation, what we are looking at are a variety of operational measures to see whether or not the system is beneficial. We are looking at the speeds in the corridor. How do the speeds compare? How are the speeds of the traffic compare to the speed limits with and without the variable speed limits? We're looking at not only the average speeds, but the 85th percentile speeds, and we're also going to look at that speed differential. So how closely are the drivers driving to the speed limits that's posted? So that's one of the things that we're looking at. We're also looking at the speed profile. So as the drivers come up on the back of that congestion, how quickly are they decelerating? Are they doing what we're asking them to do and going 60, then 55, then 50, then 50, 45, or are they just going from 70 to 30 immediately in about a half-mile segment? We're also looking at, we've done some surveys and interviews of travelers in the 3 regions to see if they've seen the signs, do they understand them, do they understand what they're supposed to do, do they trust or believe the information that's on those signs. And we're also looking at some violation behavior in the San Antonio region, looking at are people actually paying attention to them and traveling at that speed that's being posted, or are they just totally disregarding it unless there's law enforcement in the area. So that's one of the other things that we're looking at. And because we have such a short time frame, we are going to look at some of the crash data that's available, but the surrogates are going to be most likely the speeds and the speed profiles and the other items that we mentioned. So we're supposed to have a report finished for TxDOT by the middle of November, and they will turn that report around and polish it up and perfect it and give it to the legislature by the end of December. And depending on the results and what the legislature wants to do, we'll see what happens in January. So, any questions for me or my compadres? Oh yeah, a lot of hands. We have, okay, the question was, are the speed limits being enforced? They are enforceable. And I know that in the Waco district, it's just so difficult. That particular site specifically is not being enforced any different than they would enforce regularly. They're not stepping up enforcement in that area. San Antonio is very similar. And the study that what we did for violation in the San Antonio location, we went out and collected speeds without law enforcement present, and then we went out and measured speeds when there's a police officer parked next to that variable speed limit sign. Because while they weren't necessarily enforcing it, they're trying to determine is the presence or the threat of violation of getting a ticket enough to require or encourage people to drive the speed limit. And so we still haven't finished analyzing that data. I think one of the sticking point with a lot of this in the United States is most likely the most effective way to have VSL operate is if you have automated enforcement, and that's not popular in this country, especially given all our experience with red light running. So a lot of agencies are looking at that and how can we do enforcement, and is automated enforcement the way to go? In Minneapolis, their signs are not regulatory, they're advisory, and they feel that they still get enough benefit from it that it will work for them. They didn't have to make any legal changes to go that route. Washington does enforce it, but it's manual. It's very expensive and it's difficult. So right now, it's not being enforced any differently than it would be otherwise. And I think if they issue a ticket, it may be not driving to conditions or unsafe driving for the conditions, because tracking the speed and how fast the driver was going and matching those up is difficult right now. I saw another hand. Oh, a lot. You're not going to make me answer all the questions. Right, and we just can't do it right now. Right. Correct, and so the enforcement piece is something we can't. It's nominal what we can do within this short time frame. Yes, you're next.
The question was about the end of queue system. Have we had experience with longer duration, 2 to 3 months, versus the nightly deployments that we do for 12 hours? The vendor that we're using and the contractor that we're using has that experience, and originally that's how the technology was designed. And using it on a 12-hour deployment is a unique use of the system. So I personally do not have the experience, but the two guys in front of you do have the experience that are right here in the row in front of you. So you could talk to them afterwards about the long-term system. We did find, because we deploy them nightly and every 12 hours, and because they get moved around, you know, when you start throwing stuff around, you start finding the weaknesses in the system. So we had some wires start coming loose. We were having nights where one or two of the sensors weren't sending data, and we were finding out that there was a problem in the switch or some of the wiring, and that was kind of beefed up, and now it's operating just fine. So that's the thing, is it came out of the long-term deployment, and you could talk to the gentleman afterwards. So.
Those two.